In question 1, we have to find the coefficient of x square in the expansion of 2 plus x upon 2 to the power 6 plus a plus x to the power 5, and the coefficient is 330. We have to find the value of the constant a. Now the expansion formula for a plus b to the power n is a to the power n plus nc1 a power n minus 1 b power 1 plus nc2 a power n minus 2 b to the power 2 and so on. Now, as in both the cases, the power of x is 1. So, for the coefficient of x square, we'll take the term nc2 a to the power n minus 2 b to the power 2. So, first applying this formula on the first term, which is 2 plus x upon 2 to the power 6. So, we'll apply 6c2. So, in place of a, we have 2. So, this will become 2 to the power 6 minus 2, which is 4, and x upon 2 to the power 2. So 6c2 multiplied by 2 to the power 4. So 6c2 is 15 times 2 to the power 4 is 16 times x squared upon 4. Simplifying this, we will get 15 times 4. So the coefficient of x squared is 60. Now in the expansion of a plus x to the power 5, we'll again apply the same formula. We'll have 5c2. In place of a, we'll have a to the power 5 minus 2. In place of b, we'll have x to the power 2. So 5c2 is given by as 10. So this will become 10a cube x squared. Now the coefficient of x squared is 330. It means that the sum of 60x squared and 10a cube x squared will be equals to 330. So we can write this as 60x squared plus 10a cube x squared is equals to 330x squared. As we have to compare the coefficients, so the coefficient on the left hand side will be, for x square will be 60 plus 10a cube, and on the right hand side it is 330 is x squared. So x square will cancel out and we'll have 60 plus 10a cube is equals to 330. 330 minus 60 is 270, so 10a cube is 270. A cube will be is equals to 270 divided by 10, which is 27. So the value of a will be the cube root of 27, which is equals to 3. In question 2, we have the equation of a curve y equals to x square minus 6x plus k, where k is a constant. We have to find the set of values of k for which the whole of the curve lies above the x-axis. Now, normally in a quadratic curve, it cuts the x-axis at 2 points or 1 point, and we put our equation equals to 0. So we write x squared minus 6x plus k equals to 0. Now, as it says the whole of the curve lies above the x-axis, it means there are no points of intersection with the x-axis. So, and as we have an unknown constant, we know that in a quadratic equation, if we have an unknown constant, we apply the discriminant, which is b squared minus 4ac. And as there are no points of intersection, as we are assuming that, as the question says that the curve lies above the x-axis, it means that b squared minus 4ac will be less than 0. So in the question, the value of b is minus 6, minus 4 times the value of a is 1, and the value of c is k. It is less than 0. So this will become 36 minus 4k is less than 0. Rearranging, this will become 36 is greater than 4k. So k will be greater than 36 upon 4. So the value of k will be greater than 9. In part B, it is saying that it is asking us to find the value of k for which the line is a tangent to the curve. So the equation of the line is y equals to 7 minus 2x. The equation of the curve is y equals to x squared minus 6x plus k. Now, as the line is a tangent to the curve, we know that there is only one point of intersection. So first we will equate the two equations to solve them simultaneously. Rearranging, this will become x squared minus 6x plus 2x will become minus 4x plus k minus 7 equals to 0. Now, because of the unknown constant k, and as there is only one point of intersection, we know that b squared minus 4ac will be equals to 0. In place of b, we have minus 4. Minus 4 times 1 times k minus 7 equals to 0. So this will become 16 minus 4k plus 28 is equals to 0. So 4k, we'll take 4k on the other side, and this will be 16 plus 28, which is 44. So k will be 44 upon 4. The value of k will be 11. In question 3, we have a question which says that a company producing salt from seawater changed to a new process. The amount of salt obtained each week increased by 2%. It is given that in the first week after the change, the company obtained 8,000 kg of salt. We have to find the salt obtained in 12th week after the change. Now, as we know that the increase or decrease is by a percentage, we know it is a geometric progression where the first term is 8,000. As the increase is 2% each week, so let's say for the first week it was 100% of the amount, the next week it will be 102%, and so on. So the common ratio will be 102 upon 100. The formula for the nth term is ar to the power n minus 1. For the 12th week, we'll write it as 8,000 times 102 upon 100 to the power 12 minus 1. Substituting this value in the calculator, we'll get the value for the 12th week as 9946.99. Now, as in our AS exam, we have to give all our answers to 3 significant figures. So the answer will be rounded off to 9950. In part 2, we have to find the total amount of salt obtained in the first 12 weeks. So it means we have to find the sum of the first 12 weeks. Now the formula for sum is a into r to the power n minus 1 divided by r minus 1. So a is 8,000. The common ratio is 102 upon 100, which is 1.02. And for n, we will write 12 as it is asking for the first 12 weeks. So 1.02 to the power 12 minus 1 upon 1.02 minus 1. Now substituting this value in the calculator, so 1.02 to the power 12 minus 1 times 8,000 divided by 1.02 minus 1 comes out to be 107,296.71. Again, rounding this answer to 3 significant figures. So we'll take the first 3 terms, and as the fourth term is less than 5, so the final answer will be 107, and then we'll round off all of these numbers to 0. So this will become 0700 kgs. In question 4, we have a function such that f of x is a plus b cos x for x 0 to 2 pi. It is given that f of 1 upon 3 pi is 5 and f of pi equals to 11. We have to find the value of the constant a and b. Now, as there are two constants over here, two unknowns, so we'll be forming 2 equations and solving them simultaneously. So the first value of x is 1 upon 3 pi. So in place of x, we'll substitute 1 upon 3 pi, and that is equals to 5. Now, cos of 1 upon 3 pi is half, so the first equation will be a plus half b equals to 5. We'll make sure that our calculator is in radian mode as the domain of x is in terms of pi. For the second equation, we'll substitute x equals to pi into the equation, so it will become a plus b cos of pi, and this is equals to 11. So cos of pi, when we substituted this in the calculator, it is -1. So the second equation will be a minus b equals to 11. Now, taking LCM in the first equation, we'll get 2a plus b, and then the 2 times 5, this will make it 10. And a minus b is equals to 11. So b and b will cancel out. 3a will be is equals to 21, and the value of a will be equals to 7. Once we have the value of a, we can find the value of b. So we can use either one of these 2 equations. So we'll use the second equation, a minus b equals to 11. The value of a is 7. So b will be 7 minus 11 equals to b. So b is equals to -4. Now in the next part, it is asking us to find the set of values of k for which the equation f of x is equals to k has no solutions. Now this basically means that the function f of x, which is a plus b cos x, and as we have the values of a and b, we can write it as f of x is equals to 7 minus 4 cos of x. So if you put it equals to a constant value, which is k, now in place of, to understand this, we must understand that this k represents a line which is y is equals to k. Now line y equals to k is a horizontal line. So let's say if our graph is like this, a line y equals to k will be a horizontal line where the value of k could be anything. It could be 1, 2, 3, 4. Now we have to find the values of k for which there are no points of intersection. It means that this point on the y-axis must be above the graph or below the graph where it does not intersect. So we will write 7 minus 4 cos of x equals to k. Now to find this value of k, we'll try and find the maximum point and the minimum point of the curve. To find the maximum and the minimum point of cos function, so the maximum point is given by a plus b and the minimum point is given by a minus b. So a plus b, 7 plus 4, that will make it 11, and a minus b, 7, so 7 minus 4, that will be 3. So the lowest point is 3 and the highest point is 11. It means this value of k, which is a y value, it must be more than 11. So k can be more than 11 or k can be less than 3. As at these values, this line y equals to k will not be intersecting the curve, so there will be no solutions for f of x equals to k. In question 6, we have a diagram that shows points A and B on a circle with center O and radius R. The tangent to the circle at A and B meet at T. Now, the first thing we know that if a tangent is to a radius, the angle it makes is a right angle. So we'll make a right angle over here and over here. In the next part, it says that the shaded region is bounded by the minor arc and the lines AT and BT. Angle AOB is 2 radians. In the case where the sector area of sector AOB is the same as the area of the shaded region, show that tan theta is equal to 2 theta. Now, first of all, the area of the sector AOB will be given by, so area of sector AOB is equals to half r squared theta. So the formula for area of a sector is half r squared theta. Now, in this case, the theta is given as 2 theta, so this will become half r squared into 2 theta. We'll cancel out the 2's, so the answer will be r squared theta. For the area of the shaded region, in the first step, we will divide this into a triangle, into 2 triangles. We'll find the area of the triangle and then subtract the area of this sector, which is half of the total sector, and then we'll equal the area of the shaded region and the area of the sector. So to find the area of a triangle, we apply the formula half base into height. We already know that this length is r. To find the length bt, we know that if the total angle is theta, half of the angle will be theta. Applying tan, so tan theta is opposite over adjacent. So the opposite length is bt, so we can write it as tan theta is equals to bt upon r. So the length of bt will be given by is equals to r tan theta. So the area of triangle OBT will be given as area of triangle OBT will be is equals to half into r tan theta. And then the area of the sector will be, area of the small sector will be is equals to half r squared theta. Now subtracting the two areas will give us the area of half of the shaded region. So after subtracting the two areas, we'll multiply the answer by 2. So the area of triangle is half r squared tan theta minus half r squared theta, and we'll multiply this answer by 2 to get the total area of the shaded region. Now in the bracket, we can take half as common. So this will become half into r squared tan theta minus r squared theta. 2.5 will cancel out. So the area of the shaded region will be r squared tan theta minus r squared theta. When the question said that the area of sector AOB is the same as the area of the shaded region, so the area of AOB was r squared theta, and the area of the shaded region was r squared tan theta minus r squared theta. Taking r squared common on the right hand side, we'll get r squared bracket tan theta minus theta. R squared and r squared will cancel. when we take the negative theta on the other side, it will become 2 theta, which is equals to tan theta. And we had to prove that tan theta is equals to 2 theta. So we have tan theta, which is equals to 2 theta. In part 2, it is saying that in the case where r equals to 8 and the length of the minor arc is 19.2, we have to find the area of the shaded region. Now the formula for arc length is S equals to r theta. The arc length is 19.8, 19.2 is equals to the radius is 8, and in place of theta we have 2 theta. So 2 theta will be equals to 19.8 divided by 8, which is 2.4. So the value of theta will be 1.2. Now we already know that the area of the shaded region was r squared tan theta minus r squared theta. So to find the area of shaded region, we'll apply the form that we had already found out in the first part, which was r squared tan theta minus r squared theta. We already have the value of r, which is given as 8, and we have the value of theta, which is 1.2. Substituting these values in the calculator, so 68 square 64 times tan of 1.2, that is 164.6, and 8 squared, which is 64, times 1.2 is 76.8. Subtracting the two areas will give us the shaded region, which is 164.6 minus 76.8. So the final answer for the shaded region will be 87.8 units square. In this case, it was centimeters, so we'll write 87.8 centimeters squared. In question 7, we have a function f of x, which is 7 minus 2x square minus 12x. In the first part, we have to express it in the form a minus 2 into x plus b whole squared. Now we can use completing the square method, or we can use a comparison method. So if you use a comparison method, first of all, we'll expand the expression. This will become x squared plus 2bx plus b squared. Multiplying the bracket, this will become a minus 2x squared minus 4bx minus 2b squared. So we can first rearrange it to make it minus 2x squared minus 4bx minus 2b squared plus a. And now as we are comparing it with minus 2x squared minus 12x plus 7. So the coefficient of x is minus 4b, and in the original expression it was minus 12. So negatives will cancel out and the value of b will be positive 3. Minus 2b squared plus a will be is equals to 7. So as the value of b is 3, so this will be minus 2 times 3 squared, which will become 9, plus a is equals to 7. So the value of a will be 7 plus 18, which is equals to 25. So we can write the expression as 25 minus 2 times x plus 3 whole squared. In part 2, it is asking us to find the coordinates of the stationary point on the curve. So the stationary points are basically the turning points, which from the first expression, we know that if we have an expression of this form, this x plus, we can write it as 2 into x plus 3 whole squared plus 25, where this x plus 3, so the x coordinate will be minus 3, and y equals to 25 will be the coordinates of the turning point, which is also a stationary point. In part 3, we have to state the smallest value of k for which g has an inverse. Now g is a function 7 minus 2x squared minus 12x, and x is greater than or equals to k. Now for any function to have an inverse, it must be a one-to-one function. Now we already know that the turning point for this function is minus 3 and 25. So x is minus 3 and y is 25. And as x is greater than or equals to k, it means that the smallest value for which the function can be a one-to-one function will be 3. So the value of k will be greater than or equals to minus 3, or we can just say the value of k will be equals to minus 3. For this value of k, we have to find g inverse of x. Now to find g inverse, so we know that the function f of g of x can be written as minus 2 into x plus 3 whole squared plus 25. Now, whenever finding the inverse of a quadratic function, we must make sure that it is first converted into the complete square form. And then we find the inverse by the method where we first write y in place of the function g of x or f of x. In the next step, we'll exchange the values of x and y. So in place of y, we'll write x, and in place of y, x, we'll write y. Now making y the subject, first we'll bring the 25 on the other side. So this will become x minus 25. So this will be x minus 25 is equals to minus 2 into y plus 3 whole squared. We can exchange the numbers over here to make this a positive. So we can write it as 2 into y plus 3 whole squared. So this will become positive 2, and we'll bring the minus 25 on this side. This will become a 25 minus x. Now dividing 2 on the other side, we'll get y plus 3 whole squared is equals to 25 minus x upon 2. Taking the square root on both the sides, we will have y plus 3 is equals to the square root of 25 minus x upon 2. And then taking 3 on the other side, we'll get y is equals to square root of 25 minus x upon 2 minus 3. So this is our inverse function, which we can write it as f inverse of x is equals to square root of 25 minus x upon 2 minus 3. In question 8, we have 2 points A and B, which have coordinates h, h and 4h plus 6, 5h. The equation of the perpendicular bisector of AB is 3x plus 2y equals to k. Now, as the equation of the perpendicular bisector is 3x plus 2y equals to k, we can rearrange it to write it as minus 3x plus k, and then dividing 2 on both on the right hand side, we get y equals to minus 3x upon 2 plus k upon 2. Now looking at the equation, we can see that the gradient will be of the perpendicular bisector will be is equals to minus 3 upon 2. So the gradient of AB will be a negative reciprocal, which is positive 2 upon 3. The formula for gradient is y2 minus y1 upon x2 minus x1. We already have the gradient 2 upon 3, so we can apply this formula to the coordinates A and B. As we have only one variable, which is h, so y2 we can take it as 5h minus y1 is h upon x2 is 4h plus 6, and x1 is h, and this is equals to 2 upon 3. Simplifying the right hand side, we get 4h upon 3h plus 6. Cross multiplying, this will be 6h plus 12 is equals to 12h. So 12 will be equal to 6h, and the value of h will be 2. Now we can substitute the value of h in the coordinates. So the A coordinates will be 2, 2, and the B coordinates will be 4h plus 6 will be 4 times 2, 8 plus 6, 14, 5h, this will be 10. Now to find the value of A, we know that the line AB, the perpendicular bisector, is intersecting at this point, which is the midpoint. Now, if you're able to find the midpoint, the coordinates of the midpoint, we can substitute it in this equation to find the value of k. Now, the formula for midpoint of AB is x1 plus x2 upon 2. So this will become 14 plus 2 upon 2, 10 plus 2 upon 2. The coordinates of the midpoints are 16 upon 2, which is 8, and 12 upon 2, which is 6. Now, at this point, 8, 6 lies on the perpendicular bisector, and the equation of the perpendicular bisector is 3x plus 2y equals to k. Substituting in place of x, 8, so this will be 3 times 8 plus 2 times the value of y, which is 6. This will be equals to k. So this will be 24 plus 12. The value of k will be equals to 36. In question 9, we have a curve such that dy dx is square root of 4x plus 0.2, 5 is a point. We have to find the equation of the curve. Now, if the dy dx is given, which is square root of 4x plus 1, we can write it as 4x plus 1 to the power 1 upon 2. We will integrate both the sides to find the equation in terms of y. So we can write it as dy is equals to 4x plus 1 to the power half dx. Integrating both the sides, dy will become y. When we integrate, we increase the power by 1. So this will become 4x plus 1 to the power half plus 1, which is 3 upon 2. We will divide by the new power 3 upon 2, and also in the denominator we'll multiply it by the derivative of 4x plus 1, which is 4, and we add a constant c. So the equation will be of the form y equals to 4x plus 1 to the power 3 upon 2 divided by 6 plus c. To find the value of c, we'll substitute the given points, which are 2, 5. So in place of y, we'll have 5. In place of x, we'll put 2 plus, so 4 times 2 plus 1 will be 9 to the power 3 upon 2 to the power 6 plus c. If we substitute 9 to the power 3 upon 2 in a calculator, we'll get it as 27 upon 6 plus c. 27 upon 6 is 4.5, so 5 minus 4.5 is equal to c. So the value of c is 0.5 or half. So write a final equation as y is equal to 4x plus 1 to the power 3 upon 2 divided by 6 plus half. In part 2, point P moves along the curve in such a way that the y coordinate is increasing at a constant rate of 0.06. Now, y increasing at a constant rate means that dy by dt is given as 0.06. We have to find the rate of change of the x coordinate, which means that dx by dt is an unknown. Dy dt and dx dt are related by the formula dy dt is equals to dy dx multiplied by dx by dt. We already have the value of dy dt. We have to find the value of by dx, so we can find the value of dx by dt. So the dy dx expression was already given, which was square root of 4. So as dy by dx was square root of 4x plus 1, we'll substitute the x value, which is 2. So substituting 2 in place of x, we'll get 4 times 2 plus 1 to the power 1 upon 2. So 9 to the power 1 upon 2 is 3. Dx dt will be dy dt divided by dy by dx. Dy dt was 0.06 divided by dy dx. We get the value of dy dx as 0.02. In part 3, we have to show that d squared y upon dx squared times dy dx is a constant. So to show that, first of all, you'll find an expression for d square y upon dx square. Now, to find that, we'll differentiate dy dx again. So dy dx was 4x plus 1 to the power 1 upon 2. Differentiating it again, we'll get 1 upon 2 into 4x plus 1 to the power minus 1 upon 2. And we'll multiply it by the derivative of 4x plus 1, which is 4. So the expression for d square y upon dx square will be is equals to 2 upon square root of 4x plus 1, multiplying it by dy dx, which was square root of 4x plus 1. We can see that for square root of 4x plus 1 will cancel with square root of 4x. We left with 2, which is a constant. So we have to show that d square y upon dx square multiplied by dy upon dx is a constant. Multiplying these, we are getting 2, which is a constant. In question 10, part 1, we have to first solve the equation 2 cos x plus 3 sin x equals to 0. We can first write the equation as 3 sin of x is equals to minus 2 cos of x. Rearranging the equation, we can write it as sin x upon cos x is equals to minus 2 upon 3. We know the identity tan x equals to sin x upon cos x. So this will be written as tan x is equals to minus 2 upon 3. First, finding the basic angle, we'll do tan inverse of 2 upon 3. We'll not put the negative sign in the calculator. So finding the tan inverse of 2 upon 3, the basic angle will be 33.69 degrees or 33.7 degrees. Now, as tan is negative, we will make the basic angle in the quadrants where tan is negative. So tan is negative in the second quadrant. So we'll make 33.7 degrees in the second quadrant and in the fourth quadrant. As angle is measured from the x-axis anti-clockwise, so the first value will be for x will be 180 minus 33.7, and the second value will be 360 minus 33.7. So the two values of x will be 146.3 and the other value of x will be 326.3. In part 2, we have to sketch on the same graph on the same diagram, the graph of y is equal to 2 cos of x and y equals to minus 3. Graph of t. So we take it in intervals of 90. So let's say this is 90, this will be 180, this is 270, and this value will be 360. Now, an easier way to sketch a graph of a trigonometric function is we can simply substitute the values of x into the equation. So we'll take values of x as 0. We'll take it in intervals of 90, 90, 180, 270, and 360. So if we take y equals to 2 cos of x, if we substitute cos of 0, so cos of 0 will be 1. So 1 times 2 will be 2. So the value of y will be 2. So we can make divisions from 1, 2, and 3. And also we can make divisions in the negative axis as -1, -2, and -3. So cos of 2 cos of x, the first point is 0, 2. Cos of 90 is 0, so 2 times 0 will be a 0, so the y value will come out as 0. Cos of 180 is a -1. -1 times 2 will be a -2. So at 180, the value will be -2. Cos of 270 is 0. 0 times 2 will be a 0. And cos of 360 is a 1. So 2 times 1 will be 1, 2. So joining the points, we'll make the graph of y equals to 2 cos of x. Similarly, with the graph of y equals to -3 sine of x, we'll use the values of x as 0, 90, 180, 270, and 360. So sine of 0 is 0. So the first value will be x0 and y0. Sine 90 is 1. So -3 times 1 will be a -3. Sine of 180 is a 0. So -3 times 0 will again be a 0. Sine of 270 is a -1. So -3 times -1 will be a +3. And sine of 360 is 0. So the last value will be for y will be a 0. Joining the points, we'll sketch the graph of y equals to sine x. Now in the last part, we have to use our answers to parts 1 and 2 to find the set of values of x for which x is for which 2 cos x plus 3 sin x is greater than 0. And in the first step, what we'll do is we'll make sure that our equation looks like the graph that we have made. So we have 2 cos x and -3 sin x. So we can write this inequality as 2 cos of x is greater than -3 sin of x. We know that these were the points of intersection. The first value was 146.3 and the second value was 326.3. Now for 2 cos of x to be greater than -3 sin of x, we can say that if we move backwards from 146.3, for all these values, the cos graph, which is the green graph, is greater than the sine graph. So we can say that one of the values of x will be x is less than 146.3. And if we move forward from 326.3, we can see that the 2 cos of x graph is greater than -3 sine of x graph. So we'll say that the other value of x will be greater than 326.3. In question 11, we have a diagram that shows part of the curve y equals to x upon 2 plus 6 upon x. The line y equals to 4 intersects the curve at the points P and Q. We have to show that the tangents to the curve at P and Q meet at a point on the line y equals to x. Now, to show that the tangents meet at a point, we first need the equation of the tangents. For the equations, we need the gradient of the tangents at point P and Q and the coordinates of P and Q. Now, in the first step, we can find the x coordinates by solving the equation simultaneously. So we can write it as x upon 2 plus 6 upon x equals to 4. Taking the LCM, this will become x squared plus 12 upon 2x is equals to 4. Cross multiplying and simplifying, we will get x squared minus 8x plus 12 equals to 0. We can use our calculators to find the values of x, which will be x equals to 2 and x equals to 6. So the coordinates of P will be 2, 4 and the coordinates of Q will be 6, 4. Now to find the gradient at points P and Q, we'll first find the dy dx of the curve. So the dy dx, so to find the dy dx, we have the equation as y equals to x upon 2 plus 6 upon x, which can be written as 6x to the power minus 1. Finding the dy dx, we'll get dy dx is equals to 1 upon 2. Multiplying minus 1 by 6, we will get minus 6x to the power minus 2. So the dy dx will become 1 upon 2 minus 6 upon x squared. Now first substituting x equals to 2 to find the gradient at the point P. When we substitute x equals to 2, so 1 upon 2 minus 6 upon 2 squared, the gradient at point P will be equals to minus 1. And substituting x equals to 6, so the gradient at point Q will be equals to 1 upon 3. We'll now find the equations for the tangents at point P and point Q. So we have the coordinates of P and the gradient at the point P. So this will become y minus 4 is equals to minus 1 into x minus 2. This will be y will be equals to minus x plus 2 plus 4. So the first equation will be y equals to minus x plus 6. For the equation of tangent at point Q, we have the coordinate 6 comma 4. So this will be y minus 4 is equals to 1 upon 3 into x minus 6. Cross multiplying, we'll get 3y minus 12 is equals to x minus 6. We can write it as 3y is equals to x minus 6 plus 12, which will be equals to 3y is equals to x plus 6. Now solving the two equations simultaneously, we'll get y equals to minus x plus 6 and 3y is equals to x plus 6. Minus x and x will cancel, so 4y will be equals to 12 and the value of y will be equals to 3. To find the value of x, we'll use the first equation, y equals to x plus minus x plus 6. We'll substitute y equals to 3 over here, so this will be x will be equals to 6 minus 3. So the value of x will also be equals to 3. So as the point of intersection for the x and y value are 3 comma 3, we can say that the tangent to the curve at the point P and Q meet at a point on the line y equals to x, as the coordinates of y and x are equal. In part 2, we have to find the volume obtained when the shaded region is rotated through 360 degrees about the x-axis. We have to give our answer in terms of pi. Now to find the area of the shaded region, first we'll find the volume under the line, then we'll find the volume under the curve, and then subtract the two volumes. We know that the limits will be 6 as the x value of Q was 6 and the x value of P was 2. So first taking the equation of the line, we know that to find the volume using integration, the formula is pi times y squared. The equation of the line is y equals to 4 and the equation of the curve is x upon 2 plus 6 upon x. So the volume under the line will be given as pi. The limits will be 6 and 2. We'll take the square of 4 and then integrate it. So taking the square of 4, we'll get 16. And then integrating 16, we will get 16x. And we'll apply the limit 6 and 2. So this will become 16x. The limits are 6 and 2. And we'll keep pi as common outside, as we have to give our answer in terms of pi. So first applying 6 and then subtracting it from the lower limit, which is 2, we'll get 96 minus 32, which will be 64. So the volume under the line will be 64 pi. Now finding the volume under the curve, we will first of all whole square the equation x upon 2 plus 6 upon x. The limits will remain the same. So whole squaring the equation, we will get a square plus 2ab plus b square. So this will become x square upon 4 plus 2 times of x upon 2 into 6 upon x plus 6 upon x whole square, which will be 36 upon x squared. So this x and x will cancel, the 2 will cancel. The final equation will be x square upon 4 plus 6 plus 36 upon x squared. Integrating this equation and then applying the limits. After integration, this equation will become x cubed. So we'll increase the power by 1 and divide by the new power. So this will be x cubed upon 12. Integrating 6, it will become 6x. To integrate 36 upon x squared, we'll first bring the x in the numerator. We'll add the power by 1 and divide by the new power. So this will become 36 x to the power minus 1 upon minus 1, which can be written as minus 36 upon x. Now applying the limits 6 and 2 and subtracting, we'll keep the pi as common outside. First, we'll apply the upper limit, which is 6 cube upon 12 plus 6 times 6 minus 36 upon 6. And then we'll apply the lower limit, which is 2. So this will become 2 cube upon 12 plus 6 times 2 minus 36 upon 2. Subtracting these two values and substituting this in the calculator, we'll get the value for the volume under the curve as 160 upon 3, and we'll add pi to it. Now to find the volume of the shaded region, we'll simply subtract 64 from 160 upon 3 pi. So for volume of shaded region, we will subtract 64 pi and 160 upon 3 pi. Subtracting these two values, we will get a final answer as 32 upon 3 pi.